name is Wong. So my project is image sonification. So my project my ideas is to input image and use the image as a retrieve matrix from the image and use it as a probability matrix in the Markov chain and generate some music. So I will first introduce the algorithm of my programs. So I read the image from a library called image.io and then map it to some probability matrix, and then I send it to JMSL. I have a very important class called main scheduler, so everything is scheduled by the main scheduler. So this the main scheduler will tell the Markov table generator to get the image and return a Markov table back to the scheduler, and then the scheduler will send the Markov table to the music generator, and the music generator will compute some music shape and get it back to the main scheduler and send it to the instrument. So, and my GUI is can only control the main scheduler. So let me try. Where's my pictures? Let's try some brush. Okay. So when I was loaded, it found me an image loaded, and I should have something internal. So this is the image. So I actually use this the music job finish method, so it won't stop immediately, and it will wait for the music job to finish. So my GUI is so simple, and I only have a text box to specify the number of repeats in the music job. The music job is referred to the main scheduler music job. So this music job will run 10 times for this setup. So the first time you get some matrix from the image and make some Markov table and send it to the music generator and get some music shape back to the scheduler and send it to the instrument. The second time we will do the same thing. So,
and how much time between repeats?
Yeah, the time is.
That's when we heard these big changes in sound, right?
Yeah, this is, I call it a musical phrase. So I can actually get the zero dimension of the music shape to get the size of all the music shape in that parallel collections. By the way, I didn't really send music shape back to the instrument. I actually add, because I have multiple voice, so I add all the musical shape to a parallel collection, and I find the longest duration of all the different voices, and I return that duration to the console. So for this the first phrase is like 10.9 seconds, and I automatically assign the duration of the first phrase as the buffer. So I will actually generate 2 phrases at the beginning, and then I will wait for 10.9 seconds to update the Markov table, update the seed, and generate another.
So that 10.9 seconds is controlling the music job, the music job's repeat pause.
Yes.
Got it.
So the music job is always one musical phrase ahead of the real time one.
Got it.
So,
Cool.
so in the future, I can actually implement a video sonification, because this basically I can update it on the fly, and I can retrieve another snapshot of the video and do the same thing. And this might be difficult. So the instrument I use is the FM oscillator that I built in October.
Mm-hmm.
And the last one of our assignments. And this is one of the algorithms in the DX7. It has a free frequency modulator and one main oscillator that produces sound. So it actually has 25 parameters, a lot of index, MC ratio, a lot of ADSR and things. So I need a lot of data from that image. So the music generator here is a very long class. I divide them into 3 levels of elements. This is the high level element, which corresponds to the tone center, the number of voice, and scale. And I use a lot of interpolation and limits to map things to those variables. And the middle level is the amplitude, pitch, tempo, and articulation. I put tempo here because the rhythm is related to the tempo, so the tempo is slightly shifting. The low level is the timbre and articulation. The articulation is also influencing the timbre, so which influence some of the ADSR envelopes and the MC ratio and the mode index. So these index, the Markov index is generated from Markov chain class, which is compute and order Markov chain. So actually this Markov chain can compute any order of Markov chain. In this application, I use a second order Markov chain. So because when the Markov order is larger, so I need more matrix. The matrix size from the image should be larger in order to get a larger matrix. So I use a second order matrix, which actually has like 64 times 1,000 rows of matrix, which is almost fill up the entire image. Like here, so these I use the weight integer sequence to be the engine of my Markov table. So it will get one row from the Markov table and calculate just the next element and use that element to be the index of the row. So and then add a row to that to the weighted integer sequence and finding other elements. So, yeah. Yeah, okay. And one more thing. The data I mapped from the image to the FM sequence, FM instrument is not exactly the same. So I'm mapping 9 matrices from the image, but my instrument have 25 parameters. So actually I am combining these 9 elements to get all 25 parameters in the instrument. For example, like the timbre is controlling 4 ATSR elements and nothing. Yes.